Uh, the question that you posted, the answer to that question is uh, given here. The question, if I read out, it is in the circuit given below. When switch S1 is closed, the ideal ammeter M1 reads 5 amps. What will be the ideal voltage M2 when the switch S1 is kept open? So, if I redraw uh, this circuit, then it can be drawn like this. Okay, so here you can see I have just redrawn the previous circuit for my convenience. Here if you see, this problem can be solved in two ways. Now in the first case, when you see both uh, M1 and M2 are ideal. M1 and M1 and M2 are ideal. So when ammeter is ideal means ammeter will be short and voltmeter will be open. So M2 will be like an open circuit. Okay, so what we can do is we can solve this problem in two ways. Okay, so let me show you how you can solve it in the first way. So say first case is S1 is open, S1 is closed. So when S1 is closed, then this will be bypassed. So the circuit for that is given here. See, it is bypassed. Okay, that part, that V voltmeter will be bypassed because this will have zero resistance. So this is the circuit that will be formed. Okay, now he has given that 5 amps of current is flowing, so that 5 amps is flowing here. So you get to see that the voltage drop across this 5 ohm will be 25 volts. Okay, so now from here you can back calculate and you can calculate the value of E. Okay, and when you calculate the value of E, after that you can remove, in the second case, when the voltmeter is removed. So when the voltmeter is put into the circuit by switching off this S1, then the circuit will be looking like this. If I draw it here, then it will be an open circuit like this across this 10 ohm, because this switch is open and this will also act like an open circuit. So let me point out again, this is open and this will also act like an open circuit here. This will also act like an open circuit, so you will have nothing here. Okay, so that will be the equivalent circuit. So one way of solving is to find this voltage, and after that you can find this current also, uh, because this voltage drop and this voltage drop will be same, and then you can back calculate and you can get this value of E. That's one way of solving it. Okay, but a wiser way of solving this is by forming an equivalent circuit, or if by forming a Thevenin equivalent circuit to be precise. So how you can do that is, you can form a Thevenin equivalent circuit across this section, or rather across this section you can say. Okay, so if I form a Thevenin equivalent circuit across this section, then I will have an RTH. Okay, let's not talk about what is the value of RTH now. So uh, you can have an RTH. Okay, you have a voltage source and you have a resistance which is connected across 5 ohm. That is for the first case. Okay, so what we know here is, we already know this 5 ohm. This is 5 ohm. So if I have to write the equation, then the equation, it is already, this is 5 ohms. Okay, if I have to write this equation for this circuit, it will be VTH is equal to RTH into 5 plus 25. Okay, 5 into 5, 25. So this will be the equation. Now in the second case, when this is open, this is open. Okay, because this switch is open, let me point out again. Mm, when this is open, because this switch is open and this voltage source is open, it is open across these two. So the voltage is appearing here is VTH. Okay, so if we are able to calculate that VTH, okay, that will be the voltage drop across this voltmeter, because no current is will be flowing, and whatever is the voltage drop here, that will be the voltage drop across this voltmeter. Okay, so how we can find that out is, if we if you see this equation, if we are able to find this VTH, if you are able to find this VTH, that is the voltage drop which will be occurring when this voltmeter will come into action. Okay, so only thing which is variable here is RTH. So let us calculate what exactly RTH is. Okay, okay. So we can calculate uh, RTH. Okay, by so this is how we can calculate RTH. See, here is there is nothing, because we are calculating the Thevenin equivalent resistance here, and you can see there was a voltage source here. Here there was a voltage source here. Here, so I have replaced it by a short circuit, and because it's ideal voltage source, and now I'm trying to calculate RTH. I'm trying to calculate RTH from here, and looking into the circuit from here. Okay, here there was a voltmeter and a switch, and everything is open because of this. So, voltmeter has infinite resistance. So if you look into this circuit, you can calculate the equivalent resistance RTH. So how you can do is, see, uh, this this resistance and this resistance are in parallel, so this will contribute to 1.6 ohms. Okay, and this resistances are in parallel, it will contribute to 2.4 ohms. So if you see, then the two will be in series, 1.6 ohms and 2.4 ohms. Okay, and they will be here as 3 ohms and 3 ohms, and again it is parallel with 10 ohms. So you can calculate this, and you can see this is now this is uh, so 1.6 plus 2.4, it is 4 ohms. I have already written here 4 ohms, and then you can see that 4 ohms, 3 ohms, and 3 ohms. This will again make 10 ohms, and then 10 ohms is parallel 10 ohms, so it will be 5 ohms. So earlier our equation was VTH is equal to 5 into RTH plus 5 plus 25. So you can place this RTH here, and you can calculate 5 into 5 plus 25 is equal to 50 volts. So this is how you can get this answer. It can be done in two ways, as I already told you. The one is you can just back calculate and calculate the value of E, but that's a very lengthy process. The other process is to realize it as an equivalent circuit across that 5 ohm resistance. Okay, and you will realize that once you place a voltmeter, and it is equivalent to, the voltage drop is equivalent to the VTH across the terminals. Okay, so this is how this problem is solved. The answer is 50 ohms, 50 volts. And thank you for watching this video.